So here we're going to look at the basics of what statistics is, what data analytics is. It's a basic introduction. These are the learning goals for this set of PowerPoints. I'm going to break it into more than one video for you to watch. So generally speaking, before I move on, we'll talk about what is statistics and what do we use it for in a nutshell. Basically, statistics is a way of collecting data and using that data to make decisions. Right now, you're watching this video, you're listening to what I'm saying, and you're figuring out if you're actually going to watch the rest of the video, if you've got something else that's more important to do. And you're making that decision either to continue to watch it for a bit longer, continue to watch it to the end, or stop watching it. So right there, that's statistics and decision making in action. You're collecting the information by listening to me, watching the video. You're making a decision. That's all this subject is about. So with that in mind, let's just start looking at a couple of introductory examples. Got a whole bunch of students here taking a statistics class that were asked, what is your age? And these are the responses they gave us in here. We can take that data and put it into a table. It's easier to describe the data in a table than having it as all this data just floating around everywhere. So this would be an example of what is known as descriptive statistics, putting data into a form that's easier to understand and decipher. But data doesn't have to be just numbers. Earlier I just said watching this video, you're gathering information from it. So any facts or figures are data. And here there's a note of how large data can actually get. Data can become immensely large. If you imagine that you're on Facebook or Snapchat or Instagram, every time you enter something into those platforms, information is recorded. Can you imagine how many times you as an individual go onto those platforms? Some people don't use them at all, but most people do. How much information actually goes into those platforms? That information is stored, and they could figure out, what your likes and dislikes are, and they can actually attach them to your age, your gender, and then they could figure out, they could actually sell that information on to advertisers, and they figure out how and what to market to you, and which ways to market it to you based on the information they're collecting. So again, this is an example of how statistics works. There's a note here about data being stored on large computers. In fact, we have so much data sometimes that we don't have computers, a single computer that can hold the data. So we actually have to link computers together to actually store that data. The UPS really does track every single package. In fact, there's an app which you can download to your phone called Informed Delivery. And this app each day will tell you exactly what's going to hit your mailbox. And it will actually have a photo of the mail that's going to hit your mailbox on a daily basis, and it stores it. If you can imagine that there's 350 million people in this country, and each person gets, say, on average 2 pieces of mail, that's going to be 700 million pieces of information, pieces of mail that would go out in a single day. I'm sure it's a lot more than that, but 700 million per day. Can you imagine the size of the database that they must have to hold this data going back for several weeks, months, and years? It just becomes absolutely immense. So what do we do with this data? Why is this such a big deal? Why is it becoming such a big deal to hold data? Well, we take the original data, and sometimes it's too large to decipher, and we have to put it in an easier form. We turn it into information, and that's basically what statistics is. And the reason we're going to do that is so we can actually make decisions. The whole point of this is so we can actually make decisions. So let's look at an example. There's several examples here. Let's just pick on one. What is the effect of advertising on sales? And okay, so supposing we own a restaurant and we're selling pizza, and what we're going to do is what we may well do is say, okay, look, I'm going to actually figure out how much advertising I should be doing. So this is a graph. This is my advertising. So this is how much I spend on advertising in dollars. And up here, I'm going to put my sales. So hopefully, the more you spend on advertising, the more your sales become. So as I spend more and more money on advertising, my sales go up, which is great, so I can continue to advertise. But if at some point I notice that the curve is doing this, that means that any amount of money I'm spending on advertising beyond this amount doesn't actually lead to an increase in sales. So at that point, I have to make a decision. And what do I do with my advertising? And there could be more than one possible decision, and different people being faced with exactly the same information may end up making a different decision. But you may say, well, look, there's obviously no point in spending any more money on advertising because from this point on, because it's not increasing my sales. Another thing you may do is say, well, this form of advertising I'm using is not increasing sales beyond this amount. So any additional advertising money should not be spent on this form of advertising that I've been using, or the forms I've been using. For example, if you're actually just putting leaflets through people's doors, you can see there's no point in spending more money because you reach a saturation point where you've put leaflets through everybody's door, and you don't need to put 2 and 3 and 4 leaflets through people's doors because you're just wasting your money at that point. So at that point you can cease putting additional leaflets through people's doors, or you can actually start advertising in different ways, use different channels, say for example social media. So again, these are decisions you can make based on the information. And there's other examples that you can look at there. So basically, business analytics, which is what we're going to call, what this course is called, and it was the new buzzword, it's basically the statistics. But what is it? It's all about transforming data into insights to make better business decisions. So again, you take your data, insights is you're making it into information, and you're doing that so you can make decisions. Now, there's 3 classifications of data that we're going to look at on this course. So once we collect data, there's 3 ways we can classify it. In fact, there are more than 3, but we're only going to focus on the main 3. So the first one, the first classification of data is called nominal data. Nominal data has an AKA, also known as qualitative data, also known as categorical data, also known as labels. They all mean the same thing. So what is this? Nominal data is data which we use descriptive language to answer survey questions, for example. So if I ask you, what is your favorite color, you're not going to give me a number. You're going to say it's red, it's blue, it's green, it's mauve, it's brown, whatever, it's yellow, whatever color that you like. So you're using descriptive language to give me the answer. If I ask you what your marital status is, again, you can say I'm married, I'm single, I'm divorced. You're using language. It's not a number that you're giving me. The example here we have on this PowerPoint is if we were to ask students which school they're actually enrolled in, and some will say I'm in business school, some will say I'm in humanities, some will say I'm in education. Again, it's not a number response, it's a descriptive response. I'm describing using language what the answer is. And it doesn't make any difference with nominal data. If you're, say, for example, if you're in the business school in humanities or education, one is not better than the other. If I ask you what is your favorite color, and person says blue, the other one says green, one's not better than the other. There's no ranking. It's just descriptive language where the ranking or the order of the information is not important. So the next level of information we're going to look at is ordinal data. Now, ordinal data is again using descriptive language as we did with nominal data. However, the order is important. So right here they say that if we ask about somebody's credit rating, if I ask you your credit rating and I tell you, is your credit rating, is it excellent, is it good, is it fair, is it poor? And you tell me which one of those it is. Again, you're using descriptive language, but in this case, it makes a difference if you tell me your credit score is excellent as opposed to being poor. Well, actually, it would make a difference to, say, a bank when you go there, because if you're trying to get a loan from a bank, it will make a difference if you have excellent credit rating or a poor credit rating. If you go to the bank, going back to the previous question, they ask you if your favorite color is a bit of a silly example, and you said it's red or it's blue or it's green. It's not going to actually affect anything. But if you go and tell them what your credit score is, that it's excellent, good, fair or poor, that will make a difference to them. So the order is important, and that type of data is known as ordinal data. Now, some of you may be thinking, oh, my credit score is actually a number. And that's right, but again, they use that as a label. See, when they say your credit score is 580 or 630, that's a number that's just been made up by the credit rating bureau that is giving you that score. In fact, you may go to TransUnion, or you may go to Equifax, or you may go to different companies, and they all rate you as having excellent credit ratings. However, the actual scores could well be different. Say, for example, one company may say an excellent credit rating is considered to be one that is over 700 points. Another company may say an excellent credit rating is one that's over 800 points. And you may have excellent credit ratings with both companies, but different actual numbers. But the numbers are irrelevant. They're not real numbers. They're just numbers that the company's made up to differentiate people. They don't actually mean anything. Finally, we have interval data. Interval data also has AKAs, it's also known as quantitative data or numerical data. So interval data has different names. And what is it? Well, this is the actual numbers we're used to dealing with on a day-to-day basis, where we can actually add, divide, subtract, multiply, and it actually means something. So for example, if I've got $50 in my pocket right now, and you have $30 in your pocket right now, I can add it together and say together we've got $80. It actually means something. And I can say between us we've got $80. So on average we've got $40. So all those calculations that we normally do are actually valid. And I can compare that if I go back to, if if I go back to nominal data, so one of the things that I can ask you that would result in nominal information would be, what is your gender? Are you male? Are you female? And you may say, okay, I'm whatever you say that you are. And when I actually put that data into a computer and I want to actually do work with that data, the computer doesn't understand male and female. So I'm going to have to actually put a number in there for the computer to understand. And I could just make up any number. I could say, for example, 1 is females and 0 is males. But that number is just a label. It's just a label. It doesn't actually mean anything. It's just a way of splitting people out. So if I say 1 is females and 0 is males, it doesn't make sense to actually add and subtract the numbers, because if I say I've got, say for example, 3 males and the males are classified with a 0, I'm going to say 0 plus 0 plus 0 equals 0. What does that mean? It doesn't even mean anything. So nominal data is descriptive language, but sometimes they put numbers in, but just to split it out. Equally well, I could have said that males are A and females are Z. It's just a way of splitting them out and giving a label so I can differentiate between them. But the numbers don't actually mean anything. But the numbers do mean something for interval data. So if we're, say, for example, talking about money, well, adding and subtracting amounts of money actually makes sense. Now, when we take our data, depending on the timing of taking the data is kind of important. If I look at, say, the stock market, all the share prices, I printed them off right now, and I said, okay, this is Glaxo, and this is their share price, and this is Tesla, and this is their share price, and so on. If I do that right at this moment in time, that would be known as cross-sectional data. I'm looking at a snapshot of the data at one moment in time. On the other hand, if I'm actually looking at my my pizza sales over a period of time, so each day I record how much pizza I sold. Hopefully it's going to be on an increasing trend upwards like that. This would be an example of a time series, because I'm not looking at a snapshot at one moment in time of what's going on. I'm looking at the data over a period of time, and that would be known as time series data.